Swayam Prabha. Digital India. Educated India.
Namaskar. So, in the last class we were discussing about the Z parameters, that is also called as impedance parameters. So, in this class we will talk about admittance parameters, which are also called as Y parameters. So, let us start our discussion about the admittance parameters. So, basically the two port network in this case also can be the voltage driven or current driven. So, you can see the figure shown in the slide that you can either apply voltage at both side of the two port network, or you can apply current source at both side of the network. Now, in this case what we have to do, we have to determine the admittance parameters of the terminal currents, and when you want to determine the admittance parameter, what you will do, you will define the terminal currents, or you will express the terminal currents in terms of terminal voltage. So, if you compare with the impedance parameter, where we are expressing the terminal voltages in terms of terminal currents, here we are expressing the terminal currents in terms of terminal voltages. So, when we express terminal current in terms of terminal voltages, you will get a relationship between terminal voltage and terminal current as follows. So, you can say that I1 is some constant Y11 into V1 plus Y12 V2. Similarly, I2 can be represented as Y21 V1 plus Y22 V2. So, now these values which you have just added in the expression, when you compile them in the matrix form, it will become the current vector is nothing but the matrix of these constant terms, which are nothing but Y11, Y12, Y21 and Y22, and then multiplied by voltage vector. Now, this term can be represented in the symbolic form called Y, and this is known as Y parameters or admittance parameters. So, when you relate the terminal currents by using terminal voltages, so the multiplication factors which you will use to express the currents in terms of voltages will give you the admittance parameters. Now, these admittance parameters are expressed in Siemens. You can also say expressed in mhos, because these are opposite to the impedance. Now, the values of these parameters can be evaluated by setting V1 equal to 0 at the input port, means you will have the input port short circuited, or at the other end you will put the value of V2 equal to 0, means output port is short circuited. So, since the Y parameters are obtained by short circuiting the input or output ports, that is why they are also called as the short circuit admittance parameters. Now, let us try to find out the values of these admittance parameters individually. So, if you first set V2 is equal to 0, means the output port is short circuited. So, what you will do? You will put the value of V2 is equal to 0 in these two equations. So, you will get Y11 equal to I1 upon V1, that you will get from the first equation, and from the second equation you will get Y21 equal to I2 by V1. So, you will get Y11 is equal to I1 upon V1 and Y21 is equal to I2 upon V1. Now, in second case you now put V1 equal to 0, means input port is short circuited. So, in that case what you will get? You will get Y12. So, if you see the expression, if you set V1 equal to 0, you will get Y12 is nothing but I1 upon V2 and Y22 is nothing but I2 upon V2. So, you get rest of the two admittance parameters when you set the input port as short circuited. So, what you will tell about these admittance parameters. So, generally Y11 is termed as short circuit input admittance, Y12 is short circuit transfer admittance from port 1 to port 2, Y21 is short circuit transfer admittance from port 2 to port 1, and then Y22 is short circuit output admittance. Now, as we discussed in the previous slide, the values of Y11 and Y21 can be obtained by connecting a current source to port 1 and port 2 is short circuited. So, when you connect the current source at port 1 and short circuit the port 2, you will get the values of 3 quantities, that is V1, I1 and I2, and using these you can find out the value of Y11 and Y21. Y11 is I1 upon V1, Y21 is equal to I2 upon V1. Now, in the second case what you will do? You will connect current source I2 to the second port and you will short circuit the first port. So, in that case your V1 will be 0. So, rest of the quantities which you will obtain are V2, I2 and I1, and using these 3 quantities you will find out the value of Y12, that is I1 upon V2, and Y22, that is I2 upon V2. So, now you can summarize our discussion till now related to the calculation of Y parameters. So, you can summarize our discussion in these two figures. So, if you see this particular figure, what we are doing? We are applying current I1 to the input port and output port is short circuited. So, when you have this scenario, V2 will be 0, then you will get the value of Y11 and Y21. So, Y11 will become I1 upon V1 that you will get from input port, and then Y21 is equal to I2 upon V1. So, using current at output port divided by voltage at input port. Similarly, if you connect current source at the output port and short circuit the input port, so V1 will become 0 now. So, you will get the values of Y12 and Y22. Y12 will be I1 upon V2 and Y22 will become I2 upon V2. So, these two figures will summarize how you will find out the values of the admittance parameters. Now, when the two port network is linear and it has no dependent sources, the transfer admittance will be equal to Y12 is equal to Y21, and then if this condition holds, you will say that two port is reciprocal. So, this is similar to what we discussed in case of Z parameters calculation, where Z12 is equal to Z21 and it was linear, and it was, if it is not having any dependent source, the circuit was reciprocal. So, you can correlate the reciprocity of the two port network with respect to Z as well as Y parameters. Now, here also you can prove the particular scenario in the same way as we explained in case of Z parameters. How? Let us see these two figures. Now, in first case what we are doing? We are applying the voltage V across input port and finding out the value of current which is flowing inside the output port with the help of ammeter. Now, if you see that this particular two port network is reciprocal, it means that if you exchange the locations of voltage source and the ammeter, the quantities, that is I and V, are not going to change. So, if this condition holds, we will say that the circuit is reciprocal. Now, what will happen in case of reciprocal network? So, if the network is reciprocal, we can represent circuit with its pi equivalent model. So, what will be the values of pi equivalent? So, if you see the left leg of the pi circuit, the value of left leg admittance would be y11 plus y12, while the value of right leg admittance is y22 plus y12. Now, here since y12 is equal to y21, so you can use either y12 or y21, both will hold true, and then the branch which is connecting these two legs will have the admittance equal to minus of y12. So, if you have a reciprocal network, that network can be represented equivalently with the help of pi equivalent circuit. Now, in general, if the network is not reciprocal and you want to represent the circuit in the form of equivalent network, you can use the following figure. So, if you see the value of current I1, if you use Kirchhoff current law in the left side of the circuit, so I1 will be, since V1 is applying across the Y11, it will become V1 into Y11 plus, so this will be the value of current flowing through this, and the value of current flowing through this is Y12 V2. So, this will become Y12 V2. So, total current I1 will be equal to Y11 V1 plus Y12 V2. Similarly, the value of current I2, if you see from this figure, the value of current flowing through this leg would be V2 into Y22 plus the current flowing in this leg would be equal to Y21 V1. So, if you see these two equations, these equations are nothing but the equation which we discussed in our previous slide. So, we can say that with the help of this particular equivalent network, we can represent any two port network as shown in this particular figure. So, any two port network can be represented as an equivalent network, which would be represented like shown in the figure. Now, let us understand this particular concept with the help of few examples, so that you can understand the concept clearly. Let us see one example where we have to find out the y parameters of the circuit given below. So, first what we will do, we will use the equations, that is y parameter equations which we just saw, means these two equations. So, we will use these two equations and try to find out the y parameters of this circuit. Now, first what we have to do, we will determine the value of y11 and y21. So, when you are asked to find the value of y1 and y21, we will connect one current source I1 in the input port and we will short circuit the output port. So, the circuit will be as shown in the figure. Now, if you see this particular figure, the 8 ohm resistor will be now short circuited because it is connected across the terminals of the output port. So, the current I2 will be flowing through 2 ohm resistance. Now, since this is short circuited and current I1 is flowing from the input port, we will see these two resistances in parallel. So, what will be the value of voltage V1? So, V1 we can say that I1 multiplied by the parallel combination of these two resistances. So, what we will write? V1 is equal to I1 and then 4 and 2 in parallel. So, we get V1 is equal to 4 by 3 I1. Now, since you have got the value of V1 in terms of I1, Y11 can be simply calculated with the help of this term. So, that what we will say that I1 by V1 is nothing but I1 upon V1 will be written in terms of I1. Then when you simplify, you will get the value of Y11 as 0.75 Siemens. Now, next is you will use the current division and find out the relationship between I2 and I1. So, if you see this particular figure, you need to find out the value of current flowing through 2 ohm resistance in terms of I1 with the help of current division. So, the component of I1 which is flowing through 2 ohm resistance will be equal to the value of current I2 with negative sign, because both would be in opposite direction. So, what you can write? Minus I2 is nothing but the current flowing through 2 ohm resistance, that would be 4 upon 4 plus 2 into I1. So, you get I2 is equal to minus 2 by 3 I1. Now, you know that we have calculated the value of V1 in terms of I1 and we have also calculated the value of I2 in terms of I1. We can find out the value of Y21, that is I2 upon V1, and when you simplify by putting the value of I2 and V1 in terms of I1, you will get the value of Y21, that is minus of 0.5 Siemens. Now, next task is to find out the value of Y12 and Y22. So, in this case what we will do? We will connect a current source I2 at the output port and will short circuit the input port. So, your figure will look like as shown in the slide, where the input port is short circuited. In that case, your V1 will become 0 and I2 is connected to the output port. Now, in this case again the 4 ohm resistor will be short circuited, because this will be short circuited because of the output port is short circuit. So, now when you find the value of I2, find the value of V2 in terms of I2, you will see that I2 will see these two resistances in parallel. So, what we can find out? We can find out the value of V2 in terms of I2. So, what we can write? V2 is nothing but I2 into the parallel combination of 8 ohm and 2 ohm resistances. So, when you simplify, you will get V2 is nothing but 8 by 5 I2. Now, Y22 you can simply calculate, where I2 upon V2 will be the value of Y22. So, if you put the value of V2 in terms of I2 and simplify, you will get the value of Y22 as 0.625 Siemens. Now, next again you have to use the current division, so that you can find out the value of current I1 in terms of I2. So, if you see this figure, I1 will be flowing in this particular resistance, that is 2 ohm resistance, but one leg of I2 will also be flowing through this. So, you can say that the component of I2 flowing through 2 ohm resistance is nothing but negative of the current flowing, that is negative of the current I1. So, using this you can simply use the current division and find out the value of I1 in terms of I2. So, you can say minus of I1 is equal to 8 upon 8 plus 2 into I2, that is 4 by 5 I2. Now, you have I2 I1 in terms of I2. So, you can simply calculate the value of Y12, that is I1 upon V2 equal to, you put the value of I1 as minus 4 by 5 I2 divided by value of V2 which you calculated, that is 8 by 5 I 2. So, when you simplify, you will again get the value of y 1 2 as minus of 0.5 Siemens. Now, if you compile the y parameters which you have just calculated, the y matrix will be as shown in the slide, that is 0.75 Siemens as y 11, minus 0.5 Siemens as y 12, minus 0.5 Siemens as y 21 and 6.625 Siemens as y 22. Now, if you see this particular matrix, you can easily say that y 12 is equal to y 21. Now, since we do not have any dependent source in the circuit, we can say that the circuit is reciprocal. So, in that case, what we can do? We can use the pi equivalent circuit to find the parameters directly. So, if you compare the given circuit with pi equivalent of the circuit, what you can now figure out is that the value of y 12 is nothing but minus of 2 divided basically the reciprocal of minus of 2, because this is in ohm. So, you have to convert it into Siemens. So, you can simply say that y 12 is nothing but minus of 0.5 Siemens, and which will be equal to y 21. Now, next is we need to find out y 11 plus y 12. Y 11 plus y 12 would be the reciprocal of 4 ohm, that is 0.25. Now, if you put the value of y 12 here, you will get simply the value of y 11 as 0.75 Siemens. Now, next is if you see the right leg, the value of y 22 plus y 12 will be equal to the reciprocal of 8 ohm. So, you can say y 22 plus y 21 is equal to 0.125. So, when you simplify, you will again get the value of y 22 as 0.625 Siemens. So, using the circuit pi equivalent also, you can find out the value of y parameters, as we saw in case of finding out the y parameters using equations. So, in this way, if you know that the circuit is reciprocal without going into the details of y parameter equations and then finding out the value of y parameters, you can directly use the pi equivalent circuit and find out the value of y parameters. Now, next let us see another example. Here the circuit is having one dependent current source. So, we will use the parameter equations to find out the y parameters, and we will justify that when you have the dependent source, the circuit will not be reciprocal. So, what we will do? We will again apply the same procedure which we did in the previous example. We will first apply current source, that is I 1 at the input port, and we will short circuit the output port, that is the right side port of the 2 port network, and we will find out the values of admittance parameters. So, when you have this kind of circuit arrangement, you will be able to get the values of y 11 and y 21. Now, if you see this particular circuit, let us assume that the voltage at this particular node is V naught. So, what we will do? We will apply KCL at this particular node and try to solve the equation. So, if you apply KCL at this node, you will see that current flowing in 8 ohm resistance will be V 1 minus V naught by 8. So, this is going this is the current going inside the node, others are going outside coming outside of the node. So, the summation of all 4 currents will be 0 at this node. So, using that KCL theorem will the particular law, we can utilize the equation and find out the values of I 1. So, what we can write? We can write V 1 minus V naught by 8 equal to 2 times of I 1 plus V naught by 2, because the current which is flowing through 2 ohm resistance will be V naught by 2, and then current flowing through 4 ohm resistance would be V naught, because this is short circuited. So, the potential of this node would be 0. So, you can simply write V naught by 4. Now, if you simplify, you will get the value of the. Now, let us see another thing, that when you are saying that voltage across the current flowing through 8 ohm resistance is I 1, because you are connecting the current source I 1 at the input port. So, when you connect I 1, it means that the value of current flowing through 8 ohm resistance will be I 1, but at the same time you can also say that the value of current I 1 is nothing but V 1 minus V naught by 8. So, you can say that I 1 is nothing but V 1 minus V naught by 8. So, you can put the value of I 1 in the previous equation and simplify. When you will simplify, you will get the value of V 1 in terms of V naught. So, you can say V 1 is nothing but minus of 5 V naught after simplification. So, this you have got. Now, you can put the value of V 1 in the above equation. So, you can also get the I 1 in terms of V naught. So, that is minus 0.75 V naught. Now, you know that Y 11 is nothing but I 1 upon V 1. So, you put the value of I 1 in terms of V naught and value of V 1 in terms of V naught. When you will simplify, you will get the value of Y 11 as 0.15 Siemens. Now, next task is that you need to find out the value of Y 21. So, if you see the second node, you apply KCL at this node also, what you will get? You will get the current flowing through 4 ohm resistance is V naught by 4 plus 2 I 1 plus I 2 equal to 0. So, now if you simplify, then you put the value of I 1 in terms of V naught, which you just calculated, that I 1 is minus 0.75 V naught. So, if you put the value and simplify, I 2 you will get in terms of V naught. Now, you have I 2 in terms of V naught, V 1 you also know that you calculated as in terms of V naught. You put the value of I 2 by V 1, you will get the value of Y 21, that is minus 0.25 Siemens. So, you got Y 11 and Y 21 from this circuit. Now, next task is that we will add I 2 as a current source at output port and short circuit the input port. So, when we will do that, we will get again the values of remaining Y parameters, that is Y 12 and Y 22. Now, if you see, if you apply KCL at node 1, what you will get? You will get, since V 1 is 0. So, this is 0 minus V naught by 8, the value of current I 1 plus 2 I 1 plus V naught by 2 plus V naught minus V 2 by 4. Now, here again if you see, I 1 is nothing but minus V naught by 8. So, you can put the value of I 1 in terms of V naught, and when you will simplify, you will get the value of V naught in V 2 in terms of V naught. So, you will get V 2 is equal to 2.5 V naught. Now, if you put the value of V 2 in terms of V naught and I 1 in terms of V naught, you will get the value of Y 12 as I 1 upon V 2. So, when you simplify, you will get Y 12 is minus of 0.05 Siemens. Now, at node 2 you will apply KCL. So, the summation of all currents is 0 and the current flowing through 4 ohm resistance is V naught minus V 2 by 4 plus 2 I 1 plus I 2. Now, if you simplify, you will get I 2 in terms of V naught. You can put the value of I 1 as what you just find out, that is minus V naught by 8. So, when you put the value of I 1 and simplify, you will get value of I 2 in terms of V naught. Now, you have I 2 in terms of V naught, you have V 2 in terms of V naught, you will find out the value of y 22, that is I 2 divided by V 2, and when you will put the value you will get y 22 as 0.25 Siemens. Now, in this case if you see y 12 is not equal to y 21, because y 12 you have calculated as minus of 0.05 Siemens, while y 21 is minus of 0.25 Siemens. So, you can say that this particular circuit is not reciprocal. So, with this we can close our today's session, in which we discussed about the admittance parameters. Thank you.